Okay, what is a queue? Queue, one of the type of data structure, and this is the linear and the dynamic data structure. It stores the data, and what we are storing on the stack is the same, and they are storing on the top of each of them. I design it in the FIFO manner, which is the first in, first out, okay? And the queue looks like this, and you have the data whenever you are storing here. Yes, for example, this is a queue data structure. Whenever we are adding to our inserting to our queue data structure, for example, some value, yes, of 1 or maybe 2 and 3, something like that, something this. And for adding, we have in our queue data structure, we have an enqueue, which is the enqueue, and this enqueue is the for adding, for pushing some value to our queue data structure, okay? And for deleting, and you know this for deleting, and we will be gonna delete from the first. And if you remember in our stack data structure, whenever we are deleting and some value, yes, we can push here using the push method, and we can delete using the pop method from the last what we push, okay? What we push, okay? And in our queue data structure, and we are deleting and from the first, from the here, okay, using the dequeue, which is the dequeue. Okay, we have a dequeue functions for deleting from the first, and also we can but other functions is empty, and also we have a pick functions, and we can create the iterate functions, and we can delete entire our queue data structures also, okay? And the queue data structure looks like this, okay? We are pushing here, we are adding value from the last, and we can access from the first, okay? And it looks like this. And our queue data structure, whenever you are creating queue data structures, and for example, from whenever what you are programming, what you are using, what kind of programming language you are using, from the based on you can create using the, or maybe Python list if you are using Python, or you can, or maybe you are using the C++ or Java, you can use the array. Yes, and also you can create a linked list, and based on linked list you can create the queue also. And but you know, this is the what we spoke about the stack, and the same whenever you are using the linked list, and your code will, and your stack data structures will work much faster. And you know, this is how our queue data structure looks like. We're gonna jump into the VS Code, and we're gonna create our stack data structure by using the linked list. Okay, let's do it. Okay, we're going to create our queue data structure based on linked list. And firstly, we need to create our linked list. For creating, I'm going to create a class node for data linked list. And here for defining, we're going to define the init function and the self parameter and also value. And inside, just write the self dot value is equal to value, like so, and the self dot next, just we have a next also, and is equal to none. Okay, and this is not class, and we're going to create our linked list class, and the class linked list. Inside we are just initializing our nodes head and tail, our linked list head and tail, okay? And for doing, I'm just defining the function, which is the underscore init, and with self parameter, and just write the self dot head s is equal to none, and the self dot tail is equal to none, and like so. And after that, I'm going to create the queue class. We're just creating a queue data structure, okay, based on the linked list. And the queue inside, we are just initializing our queue data structure in it, and the self, and I'm just write the self dot linked list is equal to linked list. And the base, we are just initializing our queue data structure based on the linked list, okay? And after that, and we are going to create multiple functions. First, we're going to create the two functions, which is the for iterating our queue and for adding. You know, for adding, we have a enqueue, which is the enqueue functions, okay? We're going to create enqueue function for adding the last, okay? Every time whenever we call the enqueue function, we are adding to our queue some value, okay? And as we spoke in the whiteboard, and the queue data structure is a FIFO, which is the first in, first out. It means whenever we are adding the data, we are adding the end of the data, okay? And for doing this, we're going to create the enqueue and a function also. First, we're going to create the firstly iterate function for iterating, and with self parameter inside, I'm going to write firstly I'm going to check the linked list. If there is using the linked list, is there is some value in our queue or not, okay? And if self dot linked list dot head, okay, is none, inside I'm just print the queue is empty, like so. And else, I'm gonna write the else, and here we just iterate our queue. Okay, by the first I'm gonna write the node is equal to self dot the linked list and dot heat, and then I'm just iterating using the while and the node inside. First I'm going to print node dot value, and like so, and the node is equal to every time node dot x next. Okay, let's next we're going to create our next functions also, which is the enqueue functions for adding to our queue data structure. For doing this, I'm going to define a function which is the enqueue, and inside the parentheses I'm going to give the self and the value also. And inside of us we're going to create an instance of node, which is we are adding new value to our queue. It means we are in our queue data structure based on linked list. Therefore, first I'm going to create a new node is equal to the node. Inside the parentheses I'm going to give the value, which is this, and after that, and the first I'm going to check if our self dot linked list dot heat is none. It means there is no any nodes, there's no any value in our queue. It means like so. Whenever like so, our self dot linked list dot heat is equal to new node, and also self dot linked list dot tail also equal to new node, and like so. Okay, and after that I'm going to write the else, and here I'm going to write self dot linked list dot tail. We are accessing the last node, last value in our queue, and then the next, which is the next, is equal to just the new node. Okay, this one. And after that I'm going to write the self.tail, which is the self.linked list dot tail is equal to also new node. Okay, and this is our enqueue function. Let's want to check our queue data structure. Okay, and first I'm going to create the instance of queue, which is the queue is equal to the queue, and after that first I'm going to enqueue some value, okay, to our queue data structure. First I'm going to call the queue dot enqueue. I'm going to give the value, for example, 1, and let's going to give the multiple values, and 2, and 3, and like so. Okay, and after that I'm going to iterate our queue data structure. First, queue dot iterate functions. Okay, and like so. And let's going to print. And first I'm going to write the Python, the queue and queue dot py. Okay, and you see there is we printed the correctly. Our queue data structure is working correctly because we are iterating from the first to the last. Okay, because the first in first out our queue data structure. Okay, and we're going to create our next functions also, which are some dequeuing for deleting, and pick function, and also delete entire and the queue data structure also inside values. Okay, and the first we're going to create one more functions, which is the isEmpty functions for checking, for knowing what is we have a value in our queue data structure or not. Okay, I'm going to write the def. I'm going to define the function, which is the isEmpty, and like so with the self parameter. Inside first I'm going to check if self dot linked list dot heat is none, like so. I'm going to print. I'm just return. Okay, I'm going to return true, and else I'm just return false, and like so. And also let's going to check these functions also firstly before, and I'm going to print, and the queue dot is empty. Also after adding, also print queue dot is empty, and like so. Let's open, and you see there is the first true and false as like stack what we wrote. Okay, and here also. And let's we're going to create our next functions, which is the dequeuing and the pick functions and delete functions. Let's going to create this, which is the def and dequeue for deleting. Okay, and here I'm going to write the self, and inside firstly I'm going to check if self dot is empty, the function I'm calling here. Inside, if like so, I'm going to print the queue is empty, like so. And also I'm going to write the temp. I'm going to define the new variable, which is the temporary node s, and this is equal to self dot linked list dot heat, and like so. And after that I'm going to check my queue data structure. First is using the if self dot linked list dot heat if is equal to self dot linked list dot tail, like so. It means in our queue data structure we have only one value. If like so, I'm deleting that value using the like self dot linked list dot hit is equal to none, and also self dot linked list dot tail is also none, and like so. And if not, we have some more value in our queue. I'm going to delete the first one, okay, the first one. And for doing, I'm going to write the else. The inside first, I'm going to write the self dot linked list dot hit is equal to self dot linked list dot next, which is this. Whenever I write next function, and after that, you know, whenever we are writing this, we are just defining the first node is equal to the next node, which is the second one, okay? Actually, this is in this case, the first, which is the linked list dot hit. Whenever we wrote this, it returns to that one, okay? And whenever we are accessing the second node, okay, and oh, here I'm missing the dot hit. Whenever I'm writing this one, and here we are accessing 2, okay? If like so, whenever this hit is equal to 2, it means there is no any reference to the first value. If like so, and the garbage collector deleted that one, and also that one I'm printing that value, which is the temporary node dot value, and like so. This is what we deleted, that node, okay? And this is the Enqueue function. Let's want to check it and delete that one. And here I'm going to write queue dot dequeue and save it and open the terminal, and you can see, and the first is returned. And for example, I can just comment this clearly, you will see clearly, and you see there is the first is returned, which because we deleted that one. And after that we can iterate. I'm going to print, I'm going to just write print, save it, and you see there is we printed only two values, okay? We deleted the first one, okay? And the list, we're going to create our next function, which is the pick function, for knowing what is the first value in our queue data structure, okay? And for doing, I'm going to create the function and define the function, which is the pick, and with self parameter. And the inside, first I'm going to check if self dot is empty function I'm calling. If like so, I'm printing, and the queue is empty, and like so. And oh, there's the empty. And then I'm going to write the else, and here I'm going to write I'm just write one line of code, which is the print and self dot linked list dot hit dot value, which is the first one, okay? This is pick function, it looks like. And let's want to check our pick functions of the queue, of the queue. I'm going to call this pick function and save it and open the terminal, and Python queue.py. And you see there is the pick function is we are calling this one, and this is the second, because you know we're iterating two values, which is the first value is the 2, yes, and whenever we call the pick function, and after you see top of this print function, and this is 2 is printed, which is because in our queue data structure we have our first value is a 2, okay, and like so. And also this is the last, and also we have a last function. We're going to create last functions also, which is the deleting the all value in our queue data structure. And first I'm going to define function that delete and the self, and here I'm going to write the 2 line of code, which is the self dot linked list and dot hit is equal to none, and also self dot linked list and dot tail is also equal to none, and like so. And whenever we wrote this code, and we are disconnecting all, we are just updating all and the hit and tail reference to our data, okay, to our values. It means we don't have any reference to these values. If like so, the garbage collector delete these values, okay. And let's going to check this one also. I'm gonna delete the queue and this, and after that I'm just call this function, just delete, and save it and open terminal. And you see here is that the queue is empty, which is because we deleted all the value in our queue data structure, okay? And also we're going to check what is the time and space complexity of our queue data structure. And also for iterating our queue data structure is all the linear time complexity on the worst case, which is here, yes, O(n). Time complexity is the linear, O(n), and the space complexity and the constant. And the enqueuing for adding to our queue data structure is the time complexity is the constant, and space complexity also constant, O(1). And this functions, which is the is empty, which is knowing the is empty or not, this is also the constant, bus, space and time complexity also constant. And for dequeue function, for deleting, and from the first one, from the first of the value in our queue data structure, this is also a constant time. The space and time complexity are the same constant, which is O1. And the peak function also constant, and the space and time complexity, and the delete function also constant. You see, there is the, we are just, here we are just updating the reference, which is the pointers of head and tail, and after that the garbage collector deleted, and what's the data we have in our queue data structure, okay? Which is also this one, also the time complexity constant, space complexity also constant.